disease image segmentation. The model which we use is UNet ResNet34. Okay, let me show you the data set. You can see we have two folder, train and test. In train we have two folder, images and mask. Images basically contain the original images, you can see. And see, let me show you the which part we have to segment in the images. See, this is a disease on the leaf, so we have to segment this part. Okay. Now let me show you the mask of these images. These are the mask of the images. Okay. And see, this is in a PNG format, and images is in a JPG format. Okay. So during when we want the mask path or file name, we have to change the extension. Okay, so this is a helping code which I will explain you when I will explain you this part. Okay, this code. So let me open this open this in a Jupyter. Okay, I already open it. So let me show you how you can connect your Google Colab with your Google Drive. So make sure that this is take on anyone with the link. Copy the link. Okay, just paste it here and keep this part till this pass. You can see that this is a unique ID of your dataset. Now this is a library which is useful for download the dataset from your Google Drive. Let me run this. Okay, and then let me run this also. It will unzip the file which is downloaded by the gdown from your Google Drive. Let me refresh it. See, this is a zip file and this is a dataset which we have test and train. We have only one class, Leaf Disease. Okay. Now this is we can say this is the external PyTorch external library which we have to use to upload the pre-trained model from this segmentation model PyTorch. Now these are the libraries which we use for creating the model and the data loader, and also for the learning rate and all things we have to use these libraries. Let me run it again. Now this is you can say this is the main part, this is the main function of your code, that how you have to segment the original image using the mask and the original image, how you have to segment the portion of the disease. Okay, this is the important part. So let me run it, then let me show you the result. Let me show you the result of this, then I will explain you the code line by line of it. See the result. This is the original image, this is a segmented image. Where the disease is present, we are segmented with the red color. See this. Okay, so this is let me show you how we are segmenting it. Okay, so this is a function which is segmenting it. So let me explain you this with the help of the helping code. Before that, you have to make sure that how you have to get the RGB channels from the image. Suppose this is your image in a NumPy format. Okay, this is an image of your image in a NumPy format. So how you have to get the red channel, green channel, blue channel? If you use this image triple dot comma and 0, you will get a red channel, green channel and blue channel. See this 2512 here, 2512 this one, 25 250 not 25 255 255 3 255 will be 255 3 255 128 64 192 128 64 192. Means this whole row, this whole column, not row, this whole column is act as a red channel, then this second column act as a green channel, and this third column act as a blue channel for fetching the red and green channel from your image. Now this is one thing. Now with the help of this example, I will explain you how all the calculation is going on. Okay, so suppose this is a mask in a grayscale format, and here 255 is the portion where the segmentation has to be performed, or you can say where the disease area is there. And this is the overlay. Let me show you. We are using overlay here, mp0s of size image, that same size I had created just for the explanation. This is the image. Okay, now you can say alpha basically representing is to 0.5 transparency. What this means? See this in an image. uh, you can easily see that background is not, the background is not complete, background is not completely blind, or you can say some background where you can see background area partially, or 50% transparency is there with the background, with the segmented area. Okay, that is a better use of alpha is. Now come back with the code. This is a color which we are using right now. Right now I'm using a yellow color for it. Okay, we have only one class, Leaf Disease. That's why we have one representing the class ID, and here it is representing colors. Now, mask not equals to 0 is equal to 1. What does mean? Basically, it's tell that all the, it means here, all in mask, all the values which is not equals to 0 has to change to 1. Suppose in mask 255 is not equals to 1, 255 not equals to 0, 255 is not equals to 0, so these values will change to 1. So let me show you the result. Let me run it. See, before mask 255, after using that line, will all the values which is not equals to 255 change to 1. Okay, now what is going on here? See, when we iterate over the class color I dot item, it will first give me class ID. Class ID is 1, and color will be 2, yellow color will be there. Now here class mark basically is a boolean 2D array. Mask equals to class ID, where it means that all the places where 1 is there in the mask will change it to true, and all the places where 1 is not there change to false. Ultimately we get the class marks as a boolean 2D array. Now we have to pass that boolean 2D array to the this place, because it tells that on which places you have to apply the color segmentation. See, when we suppose C will be 0, C will be 0, and 3 here means 3 channel is there, that's why RGB, that's why you are using 3. It's suppose 3, C will be 0. If C is 0 till here we first fetch the red channel of the overlay, and then we pass the class marks which tell that on which places you have to add the segmented color. Here color C will be, if suppose C will be 0, C0 will be 255. So all the places where true will be there, their value will change from 0 to 255. Let me show you the result of it. See, this is the right channel of the overlay. 255, all the places where true is there, 255 is there. Okay, same for the red and green, and same for the blue. Okay, this way we fetch the red and green and blue channel from this, using this. Basically, what is the use of overlay? Basically, overlay is used to give the portions, where the segmentation has to be applied. Okay, in a 3D format, because mask is only in a you can say only in a 2D format, but for the segmentation, for blending the images, we required a overlay in a 3D format. So to get the segmentation here, where the segmentation is performed, we want a overlay in a 3D format. That's why we are using it, so that we can get the red, green and blue channel for the segmentation. After that, this is important, you can say, main part of this, so that we after running these lines, we get the blended image, or you can segmented image. For this I will explain you this part in using this. So this is overlay red and green and blue channel of the overlay. Or you can see that in for the yellow color values is 255 for R, and G will be 255, and for the green it will be 0. Not green, for blue it will be 0. So that's why it's here, for the blue portion 0 value will be there. Okay, ultimately we get the image RGB channels and overlay RGB channels, and this is a mask which tell us on which portions we have to apply the segmentation. One important thing, so you have to consider that you have to pass a boolean 2D array in this portion. In this portion you have to pass the boolean 2D array. Okay, so that's why to pass the boolean to the array, I'm using mask is equal to 1. Ultimately, it's give me the boolean to the array where in mask all the places where 1 is there, it's turned into 0. It's turned into true, and all the places where 0 is there, it turns into false. Ultimately, we get a boolean to the array. So when we get the image red channel here, okay. So when it multiply bits, 1 minus alpha initial value is 0.5. So 1 minus 0.5 will always get me 0.5, and 0.5 is equals to 1 by 2. So 255 divided by 2, 255. Why there is no change in 255? Because mass is equal to boolean to the array which we are passing is at this portion, at this place is false is there, at this portion true is there, at this portion true is there. So but when you divide 0 by half, it does nothing change. And you can see that the one is false, and false means these two values also remain the same, but this value will change, and when you multiply with half, it's changed to 127.5. Next true portion will be this way, 128 divided by 2, 64. Okay, this way we get the calculation, and same for the overlay. When you all the places where true will be there, according to mass is equal to 1, all the values will be divided by 2, and we will get these values, and when we add these two values, we will get red channel of the blended image. And for the same calculation we get green channel and blue channel, and when we combine this red, green and blue channel, you will get ultimately the blended image. Okay, 255, 127, 125, 255, 127, 127, 255, 0, 255, 255, 0, 255, 191, 64, 192, 191, 64, 192. This way you get a blended image. Now you will get you have a question that why I am doing this whole calculation manually instead of using a function. Let me show you that thing. Okay, suppose I will not use this function. Let me comment it, and I will use this part. This part, okay, means changing things with function. The function which we use is cp2 add weight. The formula which is used by this is same, blended multiply 0.5 multiplied by base plus 0.5 multiplied by overlay. This is the same function. See the difference of this using a function when we are using the manual. You have seen that when I manually change the segmented, see the result. Brightness of means background of the image remain the same. It's not dullness in the segmented image. But when I will use this blended image formula, see the result. See, this is suppose this is a background with white, and see the change in in dullness is applied. Okay, that things I don't want. I only want to change the segmented area only. I want to affect the segmented area only. Okay, that's why I am not using this function. Or you can say it's change all the pixels value, whether it is a whether it is a, uh, whether it is a segmented area or diseases area. It's change everything. That's why I'm not use this line. I manually change the things. Now let me explain you everything here. See, I already explained you this whole part. Here, instead of using mask is equal to 1, I am passing the class mask as a boolean to the arrow, because mask not equals to 0 means all the places where 0 is not there, true will be there, and where 0 is there, true will false will be present. Okay, after that just pass this to a boolean to the array in this formula, you will get the blended image. Now let me explain each thing, each and every line. These are the directories of the images, and you already know that mask is in PNG format and image is in a JPG format. So you have to make sure that during pre-processing or everything, we have to change the extension or during image read time. Basically here all it give me the list of all the images present in this directory. Basically if you are representing the entire image, access is in a 2D format in at this part, but when we use Rebel, we will get image AX in a 1D format for the ease of iteration toward the subplots. We are plotting for 32 images, and 32 images in 32 images we only iterate 16 times because at because we are plotting segmented image and a original image at one iteration only. That's why we iterate only 16 times. This is a transparency. This is a color which we are using. Now at this time we are using red color in random choice of images, and when we get the images, we will image basically retrieve the file path of the image. After that we have to get the file path, but just give the image directory and image, and make sure when we have to create the mask, change the extension of the image with the PNG, you will get the mask path. Now read the image, convert it into a RGB BGR to RGB because CB2 read image in the BGR format. Now image read the mask in a grayscale format, and zero basically used here to read the image in a grayscale format. After that, I already told you what's the meaning of this line. Convert all the values which is greater than 0 to 1. Okay. Now just pass the image, mask, color class, and alpha. You will get a planted image. Plot that image with the set titles. Plan. I'm sure you will get the result like this. Not like this. This is the dullness of dullness. And so let me run it again. See, now dullness is not there in the images. Only the portion where the segmentation had applied is applied on the image. Okay, see this. That's why I've used this. Use the manually change the channels. Now we have to load the model for pre-trained model for segmentation. Torch.coder is available. Basically, give me the value that either we are using CUDA or of CPU, and just to make sure that model, images, tensor all will be in the same on the same device. Otherwise, it will throw an error. Okay, just from SMP upload unit a model for segmentation. With ResNet34 has a backbone. The image weights we are using image needbase, and in channel will be 3 RGB input channel. We are passing a image of 3 channel. We are not passing a grayscale image. We are passing the RGB input RGB type image. So in channel will be 3, and the classes which we have is 2. Because why 2? Because one is a background and one is a leaf disease. Just give the name leaf. Okay. Make sure that model is in the GPU. Now model is ready. Let me run it. Okay. This is a class which is helped by the data loader to load the data set and create a data loader which help us during training. Okay. So it will be leaf segmentation data set. Just pass the this is a, you can say a constructor which is used for the initialization. Pass the image directory, mask directory, any transformation. Data augmentation is there that apply to image and mask both. This basically gave me the list of all the images present in the images name in present in the image directory. All the mask images. If transform initialization is there, we have only 2 classes. Leaf and the background, and you will get confused at why we are including the leaf not leaf background, because when we use a pre-trained model, zero index value is always fixed for the background. That's why we have to include the background as a zero index value, and one for the one index value we are giving the leaf. Now this is the length function which give me how many files we are using for the training. IDX basically used for indexing the file name in the image directory and the mask directory. You can see that using this image file ADX, we will fetch the image path, image file name and the mask file name, and just read them. Conversion with the RGB to PGR to RGB, read in mask and grayscale format, and see what is the use of this here. What is line saying? NP where mask is equal to greater than means all the pixels value where which is greater than 0, convert them to 1, and 0 is remains 0 as it is. Okay, this is a line says. Okay, now if any transformation is there, apply transformation to image and mask. Transform augmentation basically contain the augmented image and mask both. You have to fetch one by one, like run the image and tense and mask, and the change the data type of mask will be long. Let me run it again. Now these are the augmentation which I applied on the images: resize, horizontal flip, vertical flip, shift, scale, rotate, random, brightness, contrast, Gaussian blur, normalization is there, and ultimately converting the image into a tensor. These is the directories of image and mask in the train directory. Just create the object of the leaf segmentation dataset. Just pass the trained image according to the parameters of the constructor. Just pass them. Train image directory, train mask directory, transformation is there. Using a tutorial library, just pass the train dataset, and batch size will be there, suffering will be there. Drop last, basically what is the meaning of drop last means dropping the last batch. If suppose a last batch contain 5 images, it should be dropped. If suppose last batch contain 1 image, then also it should have to drop. Means it drop the last batch. The loss which we are using is cross entropy loss, and optimizer which we are using is add-on optimizer, which learning rate will be 0.001. Let me run it here. Now let me show how many batches we have. We have 73 batches for train, and we have ultimately 588 images for 588 images for training. This is you can say now we have to use a train loader that mapping with the mask and the image is correct or not, because sometimes mapping is different, and during training it's affect our predictions. The classes which we have is busy and leaf. You will get confused that before using this class leaf segmentation, we have only one class, leaf. Okay, but after using this, we are having two classes, bj and leaf. So don't worry, it is just for the explanation that the zero index value is given for the background. Ultimately it will not affect your segmentations. Okay, random rendered basically select the batch size, not batch size, a number of from number of batch, select random batch number. Okay, and when we iterate over the train loader, it will check that from all the batch, it will stop only with that batch where the random batch index will get match. After that, we have the plotation. Here, what is the meaning of permute 1200 CPU numpy? What is mean? See this. What is the meaning of CPU? What is the meaning of numpy? Okay. First, the meaning of permit is image I. Basically, this image variable image contain 4 images, and mask also contain mask of 4 images. Now see, when we use permute here, when we use data augmentation, the image should change from HWC from CHW. What does mean? Means dimension of the image changed from height, width, and channel. It changed to channel height and width. So for when we use when we have to plot during plotation, this dimensions is required. The dimension which is required is height, width, and channel. This permute basically convert that channel height and width to height, width, and channel. Okay, what is the use of CPU? The CPU used is here is that we want that this image will be will flow from GPU to CPU. After that, we are converting that image because image is in a tensor format, so we have to convert that image into a numpy. That's why we are using numpy here. Same for this mask. Just go mask from CPU. We want from GPU. I want a mask should be on a CPU, and convert that tensor format of mask into a numpy, because we apply data augmentation there in a class. So at this time when we fetch this mask from this variable mask, it will is in a tensor format, so we have to convert into a numpy. That's why we are using numpy. Just pass this all thing into a function and show that image. Here, what's the meaning of break? Because if suppose I will not apply the break here, it ultimately move forward to the next batch. What we do not want that. We only want to stop at a particular iteration where our particular random batch index get on that. So let me run it. This is a yellow red color, but it's not a yellow color. It is a red color. Okay. Now we start the training. You will see that this images is highly contrast because normalization is there, and also we are using contrast augmentation. So we are applying the best loss initial value will be infinite. We've saved the model with the name bestmodel.pth. We are training it with a 200 epoch, but now I want to train it just for the 10 epoch because I want to. I already have a weight which is trained on more than which is trained on 200 epochs. So during testing time, I will upload that model and show you the predictions. Okay, this is a learning scheduler we are using. Learning scheduler basically change the learning rate value, okay, during training, which help us to avoid or overfitting and increase the accuracy. What is the meaning of optimize? Mean we have to pass the optimizer. Meaning pass reason of passing the optimizer because it optimizer is responsible for the updation of the weights. Mode means see the minimum factor 0.5 or patience 3 means you can say that after every third epoch learning rate value will be changed. It's meaning that verbose means after changing of the learning rate value you have to show the masses that at particular epoch the learning rate value change. Okay, now this is the model dot train means now we have to write it over the epoch. Model dot train basically model is a training for train mode. No means updation of the weights has to perform. Initial value of epoch train loss. When you use of epoch train loss basically means to store the loss of the train loss to train loss at each epoch, at each batch, not at each epoch, at each batch. Okay, I think. Oh, see this. I forgot the meaning of factor. Factor basically means what is the value of the learning rate. After every third epoch, its change learning rate value will be multiplied by 0.5. Means initial learning rate will get half when after every third epoch. And what is the meaning of minimum here? Minimum means learning rate value will get decreased. It will not increase. Now iterate over the train loader. Make sure that image and mask on the same device and model also is on the same device. Optimizer of zero grid means make the gradient value to 0 after after every batch iteration. This thing is important because if we do not do this after, if suppose on a current, if we do not use it, the gradient value of the previous batch iteration will get accumulated to a current batch iteration and it's affect the weights updation. Okay, that's why we do not want that. That's why we are using optimizer zero grid. Now just pass the images, pass the output and mask. It will calculate the loss. Loss dot backward basically it calculate the using the loss. It will calculate the weights values, and optimizer dot step basically updates the weights. Here the calculation perform. Here the updation perform. And then just add the loss dot item to the epoch train loss after every batch iteration. After that, when this whole for loop get over, we have to calculate the average train loss. Just use length train loader. You will get the average train loss. Now apply the scheduler loss step according to average train loss. Okay, and just print the passes. Let me run it. See your training get started. Before that, let me explain you. Now, after the training get over, it will save the model. Now I think the epoch 1 is completed. See, epoch 1 is completed. We just have train loss 0.55306. Now this is a testing time. Model name, same line. Device, what is use of device? I already told you. Load the model, same way, which I have explained you above. Okay. Load the weights. Model.eval means now model is in evaluation mode. We are not training. We are evaluating the model. This is directory. This is plotation. This alpha. I already tell you what is the meaning of that. This is for the right color. 255, comma 0, comma 0. Okay. Now transformation, I already told you what all the pre-processing you have applied to the image has to be during testing also. But do not apply all the data augmentation. Just main thing means resize is there, tensor is there, and the normalization is there. It's just important. Okay, so I have applied it. Now just random choice of image path, just keep the image path, open the image, convert that image into RGB. Sometimes then we load the image, it should always, sometimes it's chances that that image is in a grayscale format. So we have to convert that into RGB format. Okay, just apply the transform to it. Then squeeze basically add the batch dimension to the image and make sure that image should be in a device. With torch no get means there will be no operation on the gradients value. Now output is there, just pass the image tensor, and zero, what is the use of zero means we have to fetch the detail, fetch the prediction at zero index only, because if we are not passing the one image with a CHW format, but here we are passing the one image in the batch format. So ultimately we have to get, if we want to fetch our prediction of the first image in a batch which we are passing, we have to use zero here. Predicted mass dot argument output dimension, this way you will get the predicted mass. What is the use of CPU here and numpy here? Let me explain you one thing here, that the prediction which is made by the model is in a tensor format, and suppose tensor format. So what is the use of CPU basically, when we get a predicted mass, I want that it should be flow from GPU to CPU. And what is a numpy here? Numpy basically mean that I want to change that the prediction which is made by the output is in a tensor format. I want to convert that into in a uh, numpy format, so that I can easily pass that into my function which is used create overlay and blend. Okay. Now original width and height, image size. What's the use of this? Because I want to make a mask, I want to, the predicted mask, I want to convert that height and weight according to the image. That's why only it will blend completely to the image. Otherwise it's throw an error that particular index is not there, particular that is insufficient index. It's all error will not occur if we do make the mask of the same image width and height. So just pass the image width and height horizontal path with using a CPU to resize and interpolation CPU in nearest. What is the use of this? During the resize, if suppose the pixels value will not get fitted, so it should be fixed. It should be filled with the nearest pixel value which is there. Now np.array image, convert the image into a numpy format. I already told you that why we are converting it, just for the plotation and just for the mathematical operation which we have to perform on the images. Okay, then pass the image mass and color mass, just plot this. This is segmentation. Here also we are plotting 16 time, but we are plotting 32 images. Same thing. Original image with the segmented image. See our training got over. Let me save that model. Now let me run this. So see the result. You can see that our model is pretty good, working well with the segmentation area to highlight the disease part on the images. Okay. But you can see that on some images it's not perfectly working, but you can make the accuracy increase. Just to increase the epochs, you will get that nice accuracy of the disease part. Okay, so my explanation is over. So please like, share, subscribe, so that I can explain you more in detail way like this only.